solve the initial value problem O.D.E given second derivative of y with respect to x plus y is equal to 0, whereby the initial value condition are at y is equal to 0, which is equal to 4, and the y prime of 0 is equal to 0. So the first thing that you do, it is to solve this equation. Our O.D.E, we are going to let our y be equal to exponential mx. Then we get our y prime, which is equal to m exponential mx. We get our y double prime, which is equal to m squared exponential mx. So we substitute here. Note that second derivative of y with respect to x is the same as y double prime, and first derivative of y with respect to x is the same as y single prime. So we substitute here, we shall have m squared exponential mx plus exponential mx, which is equal to 0. Now from this one, we can factor out exponential mx because it is common, to be left with m squared plus 1, which is equal to 0. Now, in this case, exponential m squared plus 1 is the one which is equal to 0, meaning that our m squared is equal to -1. So m is equal to square root of -1. Square root of -1 is equal to plus or minus i. Now, for a complex root which are repeated, the general solution is given by y is equal to exponential alpha x into bracket cos of beta x plus sine of beta x, you close the bracket. Now, in our case, alpha is equal to 0, beta is equal to 1 from here, meaning that our general solution will be given as y is equal to exponential 0x into bracket cos of x, substituting in beta with 1, plus sine of x. Now, any number exponential power 0 is equal to 1, so y is equal to cos of x plus sine of x. That is our general solution. Then from there now, we are going to apply the initial condition. Given is that y is equal to 0 is equal to 4. Here it means that the value of x is equal to 0 when y is equal to 4. That is the meaning of the first initial condition. So y is equal to c1 plus c2 sine of x. Note that there is a constant here, c1. This other part here, c2. Here there is a constant, c1, c2. Y is equal to c1 cos of x plus c2 sine of x. So that is the general solution. So applying the initial condition, we shall have the following. Y is equal to 0 is equal to 4. It means x is equal to 0 when y is equal to 4. Now we substitute 4 is equal to c1 cos of 0 plus c2 sine of 0. Now 4 is equal to c1 multiplied by 1 plus 0. Note this that cos of 0 is equal to 1 and sine of 0 is equal to 0. So this means that our constant C1 is equal to 4. Then the other condition we are given y prime at 0 is equal to 0, meaning that x is equal to 0 when y prime is equal to 0. So from y is equal to C1 cos of x plus C2 sine of x, it means that we have obtained our value of C1, so we can write it as y is equal to 4 cos of x plus C2 sine of x. Then to apply the initial condition, we get y prime, which is equal to negative 4 sine of x plus C2 cos of x. So we substitute the initial condition, 0 is equal to negative 4 into bracket sine of 0 plus C2 cos of 0. So 0 is equal to negative 4 multiplied by 0 plus C2, 0. 0 is equal to 0 plus, this is 1, sorry. Cos of 0 is 1, so this is 1 plus C2, meaning that our C2 is equal to 0. So our solution for the given initial value problem will be y is equal to 4 cos of x. That is our solution for the given O.D.E, which was of this form, y double prime plus y is equal to 0. And we are given the initial condition as y0 is equal to 4 and y prime is equal to 0. So that is the solution. Thanks so much for taking your time to study with me. For further examples of that nature, kindly turn to or tune to my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation.